Hi everyone, this is Babaiah, Assistant Professor of EC Department, MLR Hyderabad. Now I am going to explain about the standard test signals. Previous session we learned what is mean by time response, what are the parts are included in time response of the any system, how to calculate the or how to calculate the time response. All these we learn for the from the previous session, right? Now today now in this class we are going to learn some of the standard test signals, right? Here just to move on to the what are the characteristics of standard test signals. This is the today's overview, and as well as some types of the standard test signals are we have step signal, unit step signal, ramp signal or unit ramp signal, parabolic signal, unit parabolic signal, impulse signal, and here just observe unit step signal, unit and ramp signal, unit ramp. Okay, unit and here also unit ramp signal, unit parabolic signal, right? Here all these we are going to learn from the today session. Let now let's move on to the first. What are the characteristics of the standard test signals? Here for standard signals, by using the standard test signals, we are going to just check the every system or else check the performance of the control system. For that purpose we are going to use the some standard test signals or test signals. For test signals, now just we are going to apply the any test signal to the particular system, and we are going to just observe the what is the output and how it is perform and how it is gives the accurate outputs. These all are we observe, or we are going to observe all these from by applying the any test signal to the system, right? For standard test signals are here. See, the standard test signals are the signals which are used to check the control system performance using the time response of the output, time response of the output or time response of the system. Okay, here see, every standard test signal or in standard test signals is nothing but the simply test signals or else signals like ramp signal, parabolic signal, impulse signal. Okay, all these are the test signals, or sinusoidal signal also test signal. By using these test signals we are going to check the performance of the respected system, right? Here what are the characteristics of the test signals? Just the characteristics of the test signals, some of the characteristics are available in every standard test signals. The test signals here, the characteristics of the test signals are the actual or the sudden shock or a sudden change or a constant velocity and also constant acceleration. These are the characteristics these are the characteristics of the any standard test signals. Input signals are an actual input signal or test signals, right? Here what are the characteristics here? Simply a sudden shock, a sudden change, and a constant velocity and a constant acceleration. All these are the characteristics of the standard test signals, right? Next, coming to the first standard test signal, that is the step signal. Now I am going to just take the first one is the standard test signal as a step signal or unit step signal. What is mean by step signal? The step signal is a signal. Simply we say the step signal is a signal whose values changes from 0 to a at t equals to 0. The remaining conditions are remaining conditions, it will be going to be the constant at for a t greater than 0 condition. When t equals to 0 condition, the values changes from 0 to a. That is the step signal. The remaining condition t is greater than condition, it is a constant. It is a constant. So here just observe from the graphical representation. This is the graphical representation of the step signal. Just here observe the input is T. Here the R of T is the input signal. This one is the in x-axis T time, and R of T is our input. Every standard signal as a input to the as an input applied to the any control system. Here R of T is the input, and here A is 1 unit. Here A equals to the step signal simply from 0 to A. 0 to A, T equals to 0 condition. When T equals to 0 condition, it is equals to the A. It is the A. That is nothing but the from 0 to A value it is going. So this one is nothing but the step signal. Step signal. In remaining condition, it is a constant value. So the steps, and one more thing, the step signal is this step signal, it like a or resembles, or else it is like a, or it is give some give as a steady state or a steady input. It is like a steady input to a system. Here observe the step signal resembles an actual steady input to the system. In some cases, when we are going to call it as a unit step signal, here just simply in special case of step signal or a special case of step signal, we are going to consider A is unity. Then we call it as the unit step signal. Here see, in special case of step signal, unit step signal is unit step when A is unity condition or A equals to 1 condition. It is the unit step, and it is resembles like a study input to a system. The mathematical representation of the this one is the mathematical representation of the step signal. Here observe the mathematical representation of step signal is the when input R of T here 1, if it is T is greater than or equals to 0 condition, it is a 1 condition. Greater than or equals to condition, it is a 0, and remaining less than condition, it is going to be 0, right? It is a 0 condition. See here, equals to 0, equals to 0, and remaining this one is totally constant, so it is 1 only. Here also 1 only, here also 1 only. If it is, we are going to consider the unity, so A equals to 1, this value is completely 1, 1, 1, 1. For the T equals to 0 also, T equals to 1, 2, 3, so on up to infinity. Means here T is greater than or equals to 0. Greater than 0 or greater than or equals to 0, that in step signal it is a 1. The input is 1. If it is equals to 0, if it is equals to 0, remaining condition. Here remaining state, or this is the T is less than 0 condition. T is less than 0 condition, it is 0. T is greater than or equals to 0 condition, the input of the step signal is a 1. Input of step signal is a 1. Next, coming to the second signal is ramp signal or unit ramp signal. The ramp signal is here, we observe the ramp signal is a signal. Here this one is a ramp signal, also a signal, and whose values increases linearly with time, whose values are increases linearly with time from an initial value of 0 at t equals to 0. At t equals to 0, that is at t equals to 0, initial value of 0 at t equals to 0 conditions. So here just observe in graphical representation, and also the ramp signal resembles a constant velocity. Here this is the constant velocity input to the system. Constant velocity input to the system. A special case of ramp signal is a unit ramp signal when the value is A equals to unity. When A equals to unity condition, in special case of ramp signal acts as a unit ramp signal. And coming to the mathematical representation of the ramp signal is here. Just observe, when t is greater than or equals to 0, t is greater than or equals to 0, 0, 1, 2, 3, so on here, t is greater than or equals to 0 condition, it is going to be at. The input of this ramp signal is a and t. And here if t is less than 0 condition, it is a 0 only. The input of the ramp signal when the t is greater than or equals to 0 condition, it is a 80, and it is less than 0 condition, it is equals to 0, right? Next, coming to the third signal, parabolic signal, or else a unit parabolic signal. Just here observe, in parabolic signal, the instantaneous values, here observe, the instantaneous values are where is square, here square of the value, here 0.5, here 1 square of the time, this one is the time, t equals to 0, 1, 2, 3, so on, square. So square of the time from an initial value at 0 at t equals to 0, and here observe instantaneous values, here a t square, a t square value. So here observe 0, 1, 2, 3, so on, t up to t equals to 0, t equals to 1, 2, 3, so on, like here the instantaneous values are going to be square of the time, square of the time from an initial value 0 at t equals to 0. This is known as the parabolic signal. Parabolic signal, just here observe, the instantaneous values where is square of the time from initial value 0 at t equals to 0. The sketch of the signal with respect to the time resembles like a parabola, parabolic signal, or else it is a constant acceleration, constant acceleration input to the system. Parabolic signal resembles like a, or resembles a constant acceleration input to the system. And in a special case of parabolic signal, it is a unit parabolic signal when a equals to unity. Coming to here, mathematical representation of the parabolic signal, here r of t, the input signal, when t greater than or equals to 0 condition, it is a t square by 2. Here see, observe, for example, t equals to 1, I am going to substitute, or else t equals to 1, here t equals to 1 and a equals to 1, unity. So here 1 divided by 2 equals to 0.5, or a 0.5, or directly we are going to consider the a only 0.5a, this one 0.5 a only. Okay, so like that, it is square by t equals to 1 and t equals to 0, you will get all these values, 0.5a and 2, here 2 square by 2, so here 2a. Next 3 square, 3 square means 9, 9 by 2 equals to 4.5, like that, and so on. The square of the values, instantaneous squares of the values from initial value 0 at t equals to 0. This is nothing but the parabolic signal. Just observe previous ramp signal also, here t equals to, for example, going to 0 consider. Here t equals to 0 is nothing but here the t greater than, here 0 value only. Next here t equals to 1 condition, here we will get the a only, so 1a. Next 2 only, 2a, like that we are going to get the values, increases, linearly increases. That is the ramp signal, and this is the parabolic signal, right? Next, coming to the impulse signal, here just observe, impulse signal is nothing but a signal of very large magnitude. This is the signal of very large magnitude which is available for very short duration is called the impulse signal. Nothing but it is a signal of very large magnitude, a signal of very large magnitude which is available for a very short duration is called the impulse signal. Ideal impulse signal is a signal with infinity magnitude and zero duration, but with a area of A. Here see, observe. Ideal impulse signal is a signal with infinity magnitude and zero duration, but the area of A. The unit impulse signal is a special case in which A is unity. So that is unit impulse. We consider as unit impulse also. Unit impulse. Okay. Next here, the mathematical representation of the impulse signal, and it is denoted by the del of t. It is denoted by the del of t, and here observe when minus infinity to plus infinity, minus infinity to plus infinity, del of t into dt equals to a. Del of t into dt equals to a here. If t equals to 0 condition, if here observe t equals to 0 condition, it is going to be infinity, means here large magnitude value. So large magnitude value del of t equals to infinity when t equals to 0 condition. T not equals to 0 condition, it all the value is going to be 0 only. Remaining condition t greater than or equal or next t not equals to greater than or less than 0. All the values are going to be 0. Here also 0, here also left and right. All the values are going to be 0 for del of t, and remaining only condition t equals to 0 condition, it consists as the large magnitude only. Okay, this one is the graphical representation, and here mathematical representation. Okay, next coming to the what is mean by impulse response. This is the impulse signal. If when we are going to apply the input signal as a impulse signal, input signal as a impulse to the any control system, we are going to get the output of that system, that is known as the impulse response. Right here, impulse response. Here next, further before impulse response, just to see the one table of standard test signals. Here observe step signal. Step signal in time domain equation of signal, r of t is the input. Right here, the step signal r of t in time domain a is there. Our unit step a equals to 1, so we get the 1. In after apply the Laplace transform to the signal r of t, r of t of Laplace of r of t equals to r of s. So like that, here a apply the Laplace to a, we are going to get the a by s, 1 divided by s for Laplace transform of the input signal r of t. Here ramp signal, consider as the ramp signal. This is the time domain equation of the ramp signal is at, and the Laplace transform of the ramp signal is the a by s square, a by s square, and unit ramp. Here time domain equation of the signal is t, and Laplace transform or in s domain of the signal is 1 by s square. Parabolic signal, coming to parabolic signal in time domain equation is a into t square by 2, and here Laplace or in s domain function of the signal is a by s cube, and here unit parabolic is t square by 2, and here 1 by s cube. Del of t, always del of t, or else impulse signal. Impulse signal, for any impulse signal, for when we are going to apply the any Laplace or z or any transfer function to the impulse signal, then we are going to get the 1 only. We are going to get the 1 only. For impulse signal of Laplace is 1, or any transfer function of Laplace is nothing but 1 only. Okay, so this is the table of standard test signals. Just you can remember all these values. For the coming classes, we are going to use all this for the problematic. Okay, next coming to the impulse response. The response of the system. Response is nothing but the output. Okay, output of the system or response of the system. Impulse, when we are going to apply the input as a impulse signal to the system, now then we will get the some output. That output is nothing but the impulse response. See here, the response of the system with input as impulse signal is called weighted function or impulse response of the system. It is also given by the inverse Laplace transform of the system transfer function and it is denoted by the m of t. The another name of impulse response is the weighted function. Keep it in mind. And impulse response is nothing but the if impulse signal is applied to the any system, we will get the some output or response. That response is nothing but the impulse response or weighting function. Always the or else in this condition here impulse response is just represented as the m of t. Just here observe the impulse response m of t equals to inverse Laplace of input signal into the transfer function. Here inverse Laplace transform of the transfer function and input. Here input signal and transfer function. Here m of s equals to g of s divided by 1 plus g of s into h of s. We consider this one previous session or previous lecture. Just here the input impulse signal is r of s is our input, right? Impulse signal of in impulse signal for in s domain is equals to 1, right? Uh, okay, here weighted function or impulse response is obtained from the input signal or from the transfer function, and also it shows the characteristics of the system. Also, the response of any input can be obtained by convolution of input with impulse response. Simply we say that convolution of input with the impulse response. Here input function, input signal, and this is the transfer function. So impulse response or weighted function is obtained from the transfer function of the system. Simply transfer function of the system. This is about the standard test signals. Just see here what are the characteristics of this. The overview here. Just observe characteristics. One, sudden change, sudden shock, and a constant velocity, a constant acceleration. Why we are going to use the test signals just to check the performance of the system. Here simply what are the some test signals are available. We consider here some of the test signals like step signal or ramp signal or parabolic signal or impulse signal or sinusoidal signal, also test signal. Here this is about the standard test signals. Okay, thank you all.